Hi Smarters, welcome back. So today we'll be focusing on probability, which is in paper 1. What is probability? So probability is a likelihood of an event occurring, right? It's the likelihood of an event occurring. So probability is always equals to 1, which is 100%, that there's 100% of an event occurring. So probability is between 0 and 1. So the 1 in probability, it guarantees that the event will occur, and the 0%, it guarantees that the event will not occur. Right? So if we want the probability of event A, it's equal to the number of outcomes, which is outcomes divided by the total or the sample, right? And then the probability of event A not occurring, right, is equal to 1 minus the probability of A. So these are known as complementary events. Complementary events, right? So sometimes the probability of event A not occurring is written as probability of A not occurring. So now we're going to look at a Venn diagram and discuss some other theorems or the rules in probability, right? So we have a Venn diagram, right? So a Venn diagram, this is how it looks like. We have event A, right? And then we have our event B. So what is happening in a Venn diagram is that if this is event A and this is event B, we have an intersection here, meaning that this is A and B. But then if we close let's say we close this circle here, right? So if we close B, we only have A, right? All of the circle is called A, and if we close our A, all the circle is called B. So the intersection means that it's A and B. So here we'll have our set, which is our sample, and then we must know that everything that is outside the circles, it's not A or B. So now let's look at the rules, right? We have a mutual exclusive event. So mutual exclusive, right, events. So mutual exclusive events in a form of a Venn diagram. This is event A and this is event B. Whatever that event A has to do doesn't affect anything on event B. Like it's like they don't need each other. Event A stands on its own and event B stands on its own. So if we want the probability of A or B, it must be equal to the probability of A plus the probability of B. So this is addition rule of mutual exclusive events, right? So R is written as the probability of A union B, right? Meaning that union, you can take it as a marriage, meaning that this thing, they become one thing. Hence, we're saying we are adding, right? So we need to know that we don't have intersection, meaning that our probability of A and B. So probability of A and B, this means it's the intersection, right? So intersection, it's equal to 0. Why? Because the events can stand on their own. So if an event is not mutually exclusive, I hope it's clear. Okay, not mutual exclusive, right? Okay, so if events are not mutual exclusive, it means that they are mutual inclusive, meaning that they have an intersection, right? So it means that if you want the probability of A or B, it must be equal to a probability of A plus the probability of B, and then you subtract the intersection, which is probability of A and B, right? So this is it. And then now we will look at independent events, right? Independent events, right? So independent events, it means that okay, let's say we have, okay, this is our Venn diagram. Let me show them in a Venn diagram. So this is how it looks like. This is our A, this is our A and B, then this is our B. Oh, sorry. So in a Venn diagram, if we close this part of B, we're going to realize that the intersection is also closed, meaning that this is going to be A only, right? And if we remove and close all our circle event A, meaning that this is going to be our B only, because it's not all the B. But then if we close this part, then all of this is event B. But then if we close also the intersection, it means that this is only B, it's B only. So that's what I left out. So for independent events, we say that event A does not affect the occurrence of event B, right? So independent events is that probability of A and B, which is the intersection, must be equal to the product of event A and event B, right? So this is sometimes written as probability of A and B, right? Meaning that it still means the same thing, right? So we're also going to look at the dependent events. Dependent events. I hope it's still visible. Okay, sorry. So for dependent events, we say that when event A occurs, it affects the occurrence of the second event, right? Meaning that we're going to state that if event A and B are dependent, it means that the occurrence of the first event, it affects the occurrence of the second event. Then we say that the probability of A and B must be equal to the probability of A multiplied by the probability of of B given that event A has already happened, right? Okay, sorry. So probability of A and B is equal to the product of probability of A multiplied by the probability of B given that A has already happened. So dependent events are also called conditional events, right? What is the condition? Is that for B to occur, A must already have happened, right? So for B to occur, A must already have happened, right? So now we're going to look at a contingency table. So how do we go about a contingency table? Hope it's still clear. So let's say you have a table like this, right? 1, 2, 3, 4, right? 1, 2, 3, and 4. So what is going to happen if this is your A and this is your B? Then this is going to be a C and D. Then total and the total. So what is going to happen? This is the sample or the subtotal. That's where it's going to be. Meaning that the one here, this is event A and C. So this is A and C, right? And then we come, because this is where they intersect. So you just draw a line horizontal and also vertical. Then where they intersect, that's where we said it's event A and C. And then again, you can go like that. So this is where A intersects D. So this is A and D, right? And then we come and say again that this is where B intersects C. So this is B and C. And again, this is where B intersects D. So it's B and D. But what we need to know, this is the total, right? So horizontally, the total, this is the total of A and this is the total of B. Going vertically, this is the total of C, meaning that you're gonna sum up here and sum up here. So this is the total of D, right? So this is how it is. Then we'll do questions on how to get this. So for now, this is it, right? We're going to do some questions on this. So we also have a tree diagram. So remember that, okay, sorry, I hope it's visible. So in a tree diagram, let's say you're given a statement that says that the probability that it will rain in Johannesburg in June is 95%. So here, when you're dealing with a tree diagram, just like we said, it's the likelihood, like probability is the likelihood. So it's either something happens or it doesn't happen. So since they told us that the probability that it will rain in Gauteng in June is 95%, meaning that this is going to be our starting point. Then we're going to have a probability that it will rain and the probability of not raining. So we said if it doesn't rain, we put a prime, right? So they gave us that the probability that it will rain, it's 95%. So 95% of rain. And then you're going to ask yourself, since we say that if you want the probability, okay, we say the probability of A naught must be equal to 1 minus the probability of A, meaning that for us to get the probability of not raining, it means that it's going to be 1 minus the percentage, meaning that it's 100 subtract 95%. So we will have 5% of no rain. And then it continues. It says that when it rains, meaning it's here, when it rains in Gauteng, the probability that the temperature in the CBD will drop below 0 degrees is 72. So when it rains, we have the probability of temperature dropping or temperature arising, right? It's either it's dropping below or it drops above 0 degrees. So we can just make our little key here that B will stand for below 0 degrees Celsius, and that A will stand for above 0 degrees 0 degrees Celsius, right? So they say that when it rains, meaning we are focusing when it's raining in Gauteng, they say that the probability that it will drop below. So we have probability dropping below and probability dropping above, right? So the probability that it will drop below 0 degrees is 72%. So we're going to say 72%, and we need to remember that our probability is always equal to 100%, meaning that we're going to say 100%, we subtract the 72% that will drop, and then we have our 28%. So it continues and say, if it does not rain, meaning that for like when it doesn't rain in Gauteng, right, the probability that minimum temperature in the CBD will drop below 0 degrees is 35%. So we have dropping below and also dropping above. So we need to remember that when it they say that if it drops below 0 degrees is 35%. So this is going to be 35%, but we need to know that they add up to 100%. So it's going to be 100 subtract 35%, which is 65%. So you can also just state here, I'm so sorry because it might not be that visible because of what I wrote here. So you can just say this is R and B, rain, and it drops below the temperature. And then we have another one that states that it rains and then it drops above the 0 degrees. And then we have another one that it does not rain and then it drops below 0 degrees. And we also have another one that it doesn't rain but it drops above that 0 degrees. So that's the lesson for today. Then we'll continue on doing questions, and that's it for today. Thank you.